last week when we were doing a couple of the problems, you guys were having I forget what example it was, but there was one where we always had to worry about the other recycling bins right there.
No, that's gonna
So anyway, like we did this last week. Remember when we took our hands, we opened up the angles, and the wider your angle was, the longer the silence would have been between your fingertips. That's what it means. That's where we're at. So what happens here is in a triangle, how many sides do you have? All right. So there are 3 sides and 3 angles. In case you didn't know that, and it's real tough to figure out. Now, what I'm talking about, you guys remember what a scalene triangle is?
Yeah.
What is it? No sides are equal. So what I'm talking about here today, I'm looking at, for this example, what's called a scalene triangle. That means that all sides are different. So in a triangle, the shortest side is always across from the smallest. Oops. Yeah. The medium side is always across from the medium angle. And the longest side is always across from the largest angle. I use double arrows because it goes both ways. The shortest side is across from, or excuse me, the smallest angle is across from the shortest side. The medium angle is across from the medium side. And then lastly, the largest angle is got to be across from the longest. I know that was a lot. I'm sure you guys can do it. I have little, but I do. Now, it also goes with the idea that when you have an isosceles triangle, what do you know? You know you have 2 sides that are the same, which means you have 2 angles that are the same. So that's why it still works like this if it happens to be they're the same. It's okay. They're still across from a corresponding side that would match. It is very, very, very simple. Excuse me. Which means I know. Before we get to that, you guys remember when we did this? We called this. Remember what this was called? Remember what that was called? We've done it. We did very. You're right. If I put all 3 of them out there, but what I'm correct. Do you know what that's called though? Okay. So this thing is exterior. Anyway, so you have what's called an exterior angle. Yeah. We use this a little bit in this section also. So do you guys agree that the 3 angles inside of a triangle, if I call it angle A, this here, A, B, and C, angle A plus angle B plus angle C has to equal 180 degrees? You guys okay with that? Okay. Now, do you also agree, if I'm calling this angle here angle C, what would angle C and angle X have to add to equal? They also have to add to 180. Okay? I know that I can say that angle C plus angle X also equals 180. Now, remember when we did algebra stuff before with proofs? Don't worry about any proofs here. But when I see this, I have 2 things that equal 180 degrees, which means those 2 things have to equal each other. Okay? So you can do this. Angles A B, C have to equal angle C. What's the same on both sides? How would you get rid of it? So that means that angles A and B have to equal angle X. Basically what this gets at is that the angle on the outside always equals the sum of the two it doesn't touch. And I think we talked about that before. Vaguely rings a bell. What's that? Yeah, it's the easiest way to say it is the sum of the two it doesn't touch. Because it touches angle C, but it doesn't touch A or B. So the outside angle always equals the sum of the two it doesn't touch. The exterior angle always equals the sum. What does sum mean? Oops. Two angles it does not touch. The exterior angle equals the sum of the two angles it doesn't touch. Super, super, super simple. Ooh, excuse me. We did that, we did that. All right. Let me rephrase this. Put the sides in order from small to large. Yeah, put the sides in order of large or small to large. How do you write sides? That's not a side. How do you label sides? How do you label a segment? What's that? Yeah. How do you put the sides in order, smallest to largest? Well, when you do this, which of those is the smallest angle? 51. So what's across from the 51? ML. So the smallest side has to be ML. What's the next smallest, or next largest angle? The next largest angle is L. So across from that is MN. And then by process of elimination, what's left? Put them in order from smallest to largest, least to greatest. A couple of different ways to write it. Remember, when you're writing out segments, it's just two letters. There's no degree symbols and all that. You use the degrees of the angles to figure out which one's going to be the larger. That's what you have to do. This would go the same way if you had side lengths. I think I have an example of that. If you go with side lengths, if I want to go label them in smallest to largest in angles, what's the longest length here? 62. So if 62 is the longest length, what has to be the largest angle? B. What's the 55 is the next one. So if I go small to large, what's the smallest angle? C. Angle C is the smallest. What's the next one? B. No, not B, I'm sorry. A, yeah. And then last but not least, put them in order from the smallest to the largest. You know, that was a lot of brain power. At least I hope it wasn't. Which means there's this weird thing that happens with triangles. It's called the triangle inequality theorem. Basically what this means, in a triangle, the sum of two sides must be greater than the third. For example, if I have the side lengths of 3, 4, and 5, I want to know if I can make a triangle with those side lengths. So what happens is you have to pick two of them, and it has to be larger. You add together, it has to be larger than the third. Which means there's just 3 things you have to check. Your checking is 3 plus 4 bigger than 5. Is 4 plus 5 bigger than 3? Is 5 plus 3 bigger than 4? So again, this is going to be real tough. 3 plus 4. Is 7 bigger than 5? Okay. What's 4 plus 5? Is 9 bigger than 3? What's 5 plus 3? Is 8 bigger than 4? Can you make a triangle with those side lengths then? That's what it means. And yes, you're right. You did something like this way back. You guys ever have a class with the chalkboard? Yeah. Gotcha. Excited? Yeah, I know. That doesn't surprise me. Okay. So again, can I have a triangle with the side lengths of 2, 8, and 11? Why? That's all it is. So the answer right away, if you're going through, what's that? So this is a big old no. Now here's the thing though, even though the other two work, yeah, not all 3 of them do. And then what happens is all 3 of them have to work in order for it to make it. I know. Okay. Which means that there's one other thing that you're going to be able to do. And this is where the high school version of this comes into play. We start doing a little bit of algebra. What you're doing is you're looking for possible sides. So what we do is list the range, or yeah, we'll call it range, of possible sides. So let's say we have a 4, an 8, and something. Remember, the sum of 2 of them always has to be greater than the third. So what we do is we write out 3 inequalities. We solve for x for each one. You have those 3 inequalities. We okay with that? The sum of 2 of them always is bigger than the third. So what's 8 plus 4? 12. What do you do for this one? How do you get x by itself? Subtract 8. What happens when you subtract an 8 from 4? Can you have a negative segment length? No. And that one you subtract 4. So what's going to happen here, guys, is that you're only going to get 2 numbers that work. You're only going to get 2 numbers that work, because the other one's going to give you a negative. And that's okay. Because that means that x has to be greater than 4. X is greater than 4, but less than 12. If I have two sides of a triangle, 4 and 8, like 4 inches and 8 inches, any other value that's between 4 and 12 inches will make a triangle. If it's 3, it won't work. If it's 12 and a half, it won't work. But if it's 4 inches and 4 and a half inches, it will, because it's greater than 4. That's all that means. Okay? That's all this means. Super, super fast, super easy to learn. The only thing is that you have to understand how your inequality signs are always going to work. All right? If you remember, that's always going to be two less than symbols at the end. Small number, bigger number. It always works. Let's show you another one. We have 3, 11, and something. Yes, ma'am. Yeah, list possible values of the third side. What do you mean? Yeah. We were just checking to see, can you make a triangle with those sides? That one, if you had all three, we just add them and see if it works. And that one didn't work, so we said no. This one is find the possible values. That's what we're doing. Same thing here. List the possible values. You just write it out in rotation. Just move the numbers right around. So again, this is real tough. 3 plus 11. What happens the next one? You get negative, so I'm not going to worry about it. It doesn't work. What's 11 minus 3? 8. It depends on how you write it. It depends on how you write it. Which means x is anywhere between 8 and 14. So notice the pattern that's emerging. What's 4 plus 8? What's 8 minus 4? What's 3 plus 11? What's 11 minus 3? Add them, subtract them. Add them, subtract them. Oops. Same idea. If it's 14, possible values. What's 14 plus 23? Oh, come on. What's 23 minus 14? Add them, subtract them. Add them, subtract them. That's all it is. Huh? Give me a number. Doesn't matter. Just give me numbers. Give me 2 numbers. All right. What's 21 plus 56? What's 56 minus 21? Yeah, ta-da! Get 2 numbers. 7 and 9. What's 7 plus 9? What's 9 minus 7? 2. Honestly, the only weird thing that they might do to you for something like this, sometimes they, where was it? I skipped a little bit by mistake. The worst case scenario is they might say 3 inches and 4 feet. What's the other possible thing? Yeah, correct. The worst case scenario here, guys, is if they give you inches and feet, and that's usually about as crazy as it goes. So one of the things I want you guys to remember, and you should all know this, how many inches are in a foot? 12 inches. How many feet are in a yard? Something else you need to know. How many feet are in a mile then? No. That's meters. How do you guys not know this? So a lot of times, that's like the worst case scenario. They might switch your units on you in terms of just feet, inches, yards, something like that. I won't do any metric things on you. But I know it's all based on I get it. My wife teaches science and that. Anyway, but when you're doing, if you ever have to convert stuff, what you want to do is you always want to take and convert to the smaller unit. That way you never have to deal with decimals or fractions or anything like that. So which of those two is smaller? Inches or feet? Inches. So how many feet are in how many inches are in a foot? So what do you do to this 4 to turn it into inches? Which is? So that gives me the possible range of values then. You add and subtract them at what? Maybe I should remind you guys how to add and subtract. 51. 45, right. Yeah. When you put them together, remember, with the small, less than x, less than 51. And that's your range of values. Really, 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 really simple stuff. Okay. Works out nicely going into break with some easy math work change. Oh. Let's do this. All right. Do those real quick. Well, if you want, there's a textbook here. If you want to just take a picture of it. Otherwise, sure you share out. Okay. I'll give you guys a little bit of time. This is pretty easy stuff today. Have a nice pace change.